Assalamu alaikum. Dear students, we will continue Chapter 8 Derivative, Part 2a. Objectives. Find the derivative of some functions. Find the derivative of some product and quotient. Let's start. Materials the same as before. Approach between function derivative and number derivative. Definition. The derivative is a function that assigns to each variable value of x the slope of the tangent line at point x f of x on the graph of f of x. Example. We want to apply the definition of derivative to prove that the slope of the tangent to the curve of f defined as f of x equal x squared at the point x squared is to x. In other words, simply, we want to prove that if the function is x squared, then the derivative function is 2x. Remember the definition of derivative. Simply apply this definition at x equal x0. Of course, factorize and simplify. So we do the steps, and as you notice here, we get the answer 2x0. So now we can deduce that if the function f of x equal x squared, then the function derivative equal to x for any value of x. This is an approach between the function derivative and the number derivative. Application. We want you to apply the definition of derivative to prove that if f of x equal radical x, then f prime of x equal 1 over 2 radical x. Okay. We apply the definition of derivative at x equal x0, as you notice here, and we rationalize and simplify and do the calculations, and we get the answer 1 over 2 radical x0. So we can now conclude that if the function f of x equal radical x, then its function derivative, the derivative function, equal 1 over 2 radical x for any value of x in the domain of function f of x. Now, definition of function derivative. We say that two intervals I and j, I subset of j, function f defined on I admits at every point of j a number derivative. The function that at each real number x0 belongs to j will correspond the number derivative f prime of x0 is called the function derivative of f on j, and it will be denoted by f prime. Derivative of some functions. You can use the definition of derivative to prove them. Remark, the domain of definition is subset of the derivative, is subset of the domain of definition of the function. Now the main point and the main idea in this chapter. These rules. Pay attention. If the function is constant, f of x equal 5, f of x equal minus 7, then its derivative equals 0. If the function equal x, the derivative equal 1. If the function equal binomial ax plus b, then the derivative equal a. If the function equal x power n, apply this rule, the derivative equal n multiplied by xn minus 1. And if the function is monomial a x power n, then its derivative is a multiplied by n multiplied by x power n minus 1. And finally, derivative of 1 over x is minus 1 over x squared, and derivative of radical x is 1 over 2 radical x. These rules, you should study them. Example. We want to find the derivative in the following cases. Of course, you should review the previous rules and apply them on the given functions. Look here. Minus 7 derivative is 0, x derivative is 1, 3x plus 2 derivative is 3, x squared the derivative is 2x, 5x cubed the derivative is 15x squared, 5 over x the derivative is minus 5 over x squared, and 7 radical x the derivative is 7 over 2 radical x. Simply the previous rules, review them. Application, do it by yourself. You should find the derivative of these two functions, then deduce the number derivative at x equal to. Okay. First, remember the rule. Now apply the rule. Minus x power 5, it is minus 5x power 4. And the number derivative here, simply we substitute x by 2. The second example, 3x squared is 6x. And the number derivative at 2, substitute x by 2. Now, if we want to use the definition of derivative of f at x equal to f prime 2 equal limit, etc., etc., okay, the previous method taken in part 1, if you complete calculation, you will get the same answer, okay? So these rules facilitate the calculation. Now, we will talk about a new rule. If we have addition or subtraction of two functions or expressions, simply we distribute the derivative over them. U plus v, u minus v, the derivative is u prime plus v prime or u prime minus v prime. Example, 3x squared plus 5x minus 1, and the other example. The first one. Remember all the rules. 3x squared plus 5x minus 1, apply derivative and distribute it here and here and here. We get 6x plus 5. The second example, minus 2x here plus 5 will become 0. Constant derivative is 0. Here it will become 3 into minus 1 over x squared plus 1 over 2 radical x minus 1 plus 0. Look at the calculation. Do the application by yourself. Okay. The first one, 10x plus 1. The second one is 2 into 1 over 2 radical x minus 2x plus 3. Simply apply the rules. Now, we will talk about the product and the quotient. Pay attention. Here we have a new rule. U times v. The derivative is u prime times v plus v prime times u. U over v. The derivative is u prime times v minus v prime times u over v squared. Pay attention. These two rules are the most important rules in our chapter. Example. These two examples, product and quotient. Apply the rule. U times v. U prime times v plus v prime times u. Look here. Okay, and then do the calculation. The second example, u over v. It is u prime multiplied by v minus v prime multiplied by u over v squared. Look here. Apply the rule. Do the calculation. Now the application. Okay. We apply the rule u prime v plus v prime u and do the calculations. And here we apply the rule u prime v minus v prime u over v squared and do the calculations. Summary. Focus on these rules and do the following assignment. And coming next, because we haven't finished all the rules, derivative of u power n, derivative of 1 over u and radical u. Thank you, dear students.